What's going on, everybody? Boris here at your College of Design Studio, bringing you episode 6 of this Learn Along series, where we try to learn Java together. In this episode, we're going to learn about arrays in Java, and let's get right to it. We have 3 programs to write, so we have no time to lose. Create a new project, call it whatever you want. I've called it arrays, and let's get started with initializing our variables. So we've initialized array, and now we declared the array, and then we created the space for the array. So now we're creating the titles for the table where we're going to display the array. And the array is basically a series of numbers stored. So instead of storing one number, the array will store multiple numbers. And here we want to end this. And what this line does is column headings. That's it. So we're creating a for statement, so when the program executes, it will check if this is true. So for int counter equals 0, we're going to do counter array is less than array dot length, and then we're going to post increment counter. Now notice here that we have %8s. That means we're limiting our string placeholder to 8 strings, to 8 characters. And now we're typing %5d. This is a integer placeholder, and we're limiting that to 5 digits. That should be, unless, well, I misspelled counter. That should be everything we need. Come on, man, get it right. Counter. All right. That should be everything we need for this program. Let's execute it and see what it does. Build successful, total time 0 seconds. This is precisely what we want to see. We want to see index value 1 all the way through 9, and then with the values of 0. And let's see what's going on. Now, the for statement on lines 8 and 9 creates or outputs the index number represented by counter and the value of each array element. The loop control variable counter is initially 0. The index values start at 0, so using 0 based counting enables the loop to access every element of the array. And we are using the value, the index value of 10. It's a 10 element array, and the highest index value of that is 9. So using the less than operator in the loop continuation condition guarantees that the loop does not attempt to access an element beyond the end of the array. Now we're going to modify our array program so that we actually declare the values of the array in the index. And we're going to delete line 5, and up in line 4, we're just going to initialize this. Remember how in some programs we wrote we could put equals 0? Well, now we'll do equals, and then in brackets, we're going to basically list 10 numbers. So say 10, 11, 12, just 10 numbers, doesn't matter what they are. Let's see, 1, 2, 3, 4, 5, 6. That should be 10. Let's check. No errors. Let's run. There it is. So what we've done is, instead of having the value of 0, we've declared that each of these numbers is going to be input one at a time in the index. So when the index value reads 0, the first number is going to be displayed. Now in this program we've made a few crazy modifications. I went ahead and typed some of it out. On line 4 we're declaring a constant variable declared as a final integer. Now final is a modifier and it declares the constant variable array underscore length as a value of 10. Now constant variables must be initialized before they're used and cannot be modified after they're declared. So we can't modify it down here in this program. It will always be 10. And we're going to initialize our array with the final variable with the final value of 10. So here we're going to need two for statements. The first one, and they're both going to read pretty much the same, but the first one is going to be for calculation purposes. We're going to calculate the value of each array element. So it's going to be 2 plus 2 times the counter. So each time it executes, it's going to be 2 times 1, 2 times 2, 2 times 3, and so on. And then we're going to print out our column headings, and down here, once we've done our first 4, and the 4s are going to be the same, we type the following. %5d, %8s. Again, we're limiting the values here to 5 and to 8. And that should be it. I don't see any errors. Let's run and take a look at what this looks like. Success. We're going to start with 2 and then times 2 times 2 or plus 2. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So let's think about this for a second and see if it makes sense. We have 2 plus 2 times the counter. So for 0, it's 2 plus 2 times 0. So it's going to be 2 plus 0 is 2. So far so good. For index value 1, it's going to be 2 plus 2 times 1. So it's going to be 2 plus 2 times 1 is 2. 2 plus 2 is 4. So far so good. And let's check this one. 2 plus 2 times 2. 2 times 2 is 4. Plus 2 is 6. And the value is going to be 6. So the calculation works flawlessly. It does exactly what we want it to do. It takes 2 and adds it to the product of 2 times the counter variable each time the product executes, all the way down to our 10th array. And I know it says 9, but we need to consider that the first index value is 0. So 0 to 9 is 10 index values stored in this array, with the last number being 20. This next program is by far my favorite because it comprises all the elements of the previous programs we wrote with a new twist. So stay with me while I type it out, and then we're going to take a look at the logic of the code, what it does, and why it makes sense to do it that way. So let's get started. Everything is the same: package array, public class arrays. Again, you can call it whatever you'd like. We have only one main class, public static void main string args. And then we begin the main program in the body here on line 4. So we've initialized our array and we've input the following values, but we need to be careful here. These are not actually going to be our values. These are going to be placeholders for categories. So in category 1 we have 0. In category 2 let's say we have 3. Category 3 we have 1. Category 4 we have 0. Category 5 we have 7. Let's get some kind of a bell curve. Maybe we have 2, 3, 5, 7. Let's do 8, 2, 3, 6, 2, 3. All right, let's go with that. So we've initialized the values of array, but think of these as placeholders, and we'll see why in a minute. Now this is just a fun statement, and let's examine what it does. We have if counter is equal to 10, system.out.printf 5d, or it should be %5d, I apologize, comma 100. Else system.out.printf %02d to 02d. And then here in the line statement, we quantify what that means. And actually we should delete this because we need this to be in the parentheses because it's still part of our statement. Let's do a comma. Alright, our program is done. We have no errors. We're just missing a little parentheses here before the 4 or after the 4. But let's take a look at the logic of the program so we can see if we can guess how the output will look like on our command line before we actually run the program. And this if statement is where the magic happens. If counter is equal to 10, print the following formatted statement. %5d, so we're limiting this to 5 integer values, comma 100. Now let's think about this for a minute. 100 only has 3 integer values, 1, 0, and 0. So I say that we're going to see something like space, another space, and then 100. So we're going to see 2 blank spaces and then 100 in the end. Else system.out.printf, this is interesting, %02d dash, not a minus, %02d counter times 10 counter times 10 plus 9. So in the first placeholder, or decimal placeholder, we have counter times 10. And in the second one here, we have counter times 10 plus 9. So say, for example, our counter is 0. So we're going to have 0 times 10. That's 0. And it should output 0, 0, because we're looking for 2 decimal placeholders. And then in a dash, it's going to output 0 times 10 plus 9. 0 times 10 is 0, plus 9 is 9. It's going to output 0, 9. So it's going to be 0, 0 dash 0, 9. And it's going to continue doing this at each iteration of the program. And I believe we have 11 values here, so it's going to read something like this. It's going to be 00 dash 09, 10 dash 19, 20 dash 29, and so on and so forth until it gets to the last line, and then it's going to print out 2 blank spaces and then the number 100. So let's see if we're right. Let's see if that's what the program does. And by the way, this is a kind of a makeshift bar chart program because it's going to print this asterisk when this for statement executes. So if stars equals 0 and the stars is less than the array counter, then post increment stars for these values here. And we'll see why there were placeholders. I mentioned there were placeholders in the beginning. We'll see why. Success, build successful. And there it is. See if we can make this bigger. Yes, we can. This is what our bar chart looks like. Grade distribution is as follows. Yes, 00 dash 09, 10 dash 19. And as you can see, we have kind of a mock bell curve with 2 peaks. It's not exactly a normal distribution. But this is what I meant when I said there were placeholders. Let's see if we can scroll up here, and yes, int array equals 0, 2, 3, 5, 7, 8. That's the number of stars we're going to output because they're placeholders for these values. So in the first index value, we have a 0 number stored, or 0 value stored. And in a second, we have 3, 5, 7, 8, 2, 3, 6, 2, and then 3. So each time the program executes, it's going to look into the array, see what number is in there, and then it's going to use that number to decide how many stars it's going to print out. And then when it does so, it's going to use the formatting here for the table. These values are not going to change. This always will be outputted, 00-09 all the way down to 100. And then the number of asterisks that are going to be printed out is going to be dependent on what the value in the array is. Now we can't put this for statement before the other one because our counter variable on which it is dependent is declared here in the first for. For integer counter initialized at 0, and for counter less than the array length, post increment counter by 1. And then if this happens, if the counter is equal to 10, so after 10 iterations of the program, then output this. Else, at each iteration, so it's going to read this, and it's going to, I guess if you want to make it more efficient, you could switch those statements. So if counter is less than 10, output this, if or else outprint this, so that it reads this line first each time. But for now, this suffices, and it looks at this statement, evaluates it, and then uses the counter, the value of the counter at each iteration, multiplies it by 10 for these values, and then it looks into the array and it looks into the counter as well. It's very important because on the third iteration of the program, it's looking into the third value of the counter. It's pulling out the value 3, and then it's printing out 3 asterisks, and then it's skipping a line, system.out.println. This brings us to the end of this tutorial, folks. We're going to be using this in the next program we write. We're going to rely on arrays, and I'm going to try to find a decent program where we can combine everything we've learned so far so we can see how it all works when we put it together. If you have any questions or comments, please let me know down below. Thanks for watching, and I'll see you next time on our Ecology Designs production.